In this video, we're going to be solving equations involving indices. Let's take a look at the first example. We've got 2 to the power of n plus 8 equals 2 to the power of 5n. And we need to solve the equation. That means we need to work out the value of the unknown. In this case, we have to find out what n is. Now, we've got two powers. We're told they are equal to each other and they have the same base. That means the indices must be equal as well. So we can say n plus 8 equals 5n. Now this is a fairly simple equation we can solve. I can subtract n from the left and the right hand sides. That gives me 4n on the right and that equals 8 on the left there. And then I can divide both sides by 4 and that will give me my solution, which is n equals 2. Pause the video and have a go at question B for yourself. Here we've got two powers, we're told they are equal, and we know the powers have the same base. So if the powers are equal and the bases are the same, then the indices must be equal as well. That means we have 2a plus 3 equals 4a minus 2. And I can solve this equation like this. So the solution is a equals 5 over 2. In all of these questions, we can check our solution by substituting it back into the original equation. If we go back to question A and we substitute n equals 2 into here, we'll see that we've got 2 to the power of 10 on the left-hand side and 2 to the power of 10 on the right-hand side. And those are equal, so this is a correct solution. Similarly, if you substitute a equals 5 over 2 into the left-hand side here, you will find we've got 7 to the power of 8. And if you substitute it into the right-hand side, you will also find we have 7 to the power of 8. That means this value of a satisfies this equation, which means we've found a correct solution. Let's take a look at question C. This time we've got 3 to the power of a minus 5 equals 9 to the power of a plus 1. Can you see why this problem is a little bit trickier than the previous two examples? Hopefully you've spotted that this time we have different bases. And because those bases are different, we can't simply say that these indices must be equal. But there's a way around this. If you've seen the previous video, you'll know that we can try to rewrite a base in terms of another base. And in this case, what I can do is spot that 9 is actually a power of 3. 9 is actually 3 squared. That means 9 to the power of a plus 1 equals 3 squared to the power of a plus 1. And so that's the right hand side, which equals 3 to the power of a minus 5. Now, looking at this right hand side, we've got a power raised to a power, and that means we can multiply these indices. So that right hand side becomes 3 to the power of 2 times a plus 1, and that equals 3 to the power of a minus 5 still. Now we've turned the original equation into one where the powers have the same base, and that means we can say the indices are equal. So a minus 5 equals 2 multiplied by a plus 1. I'm just going to expand that so it says 2a plus 2. Pause the video and see if you can solve this equation. Okay, what you should have found is that a equals negative 7. I've skipped a few steps there, but hopefully you can see how you can go from that equation to the solution. Moving on to question D. Again, we've got two powers that are equal to each other, but they have different bases. But notice that both bases, the 8 and the 4, are powers of 2. So I can rewrite each of those bases as powers of 2. So I have 8, which is 2 cubed, all raised to the power of b, and that equals 4, which is 2 squared, all raised to the power of 5 minus b. Pause the video and see if you can continue from here to solve the equation. Here's what you should have got. On the left-hand side, we have 2 cubed to the power of b, so that's 2 to the power of 3b. And on the right-hand side, we have 2 squared to the power of 5 minus b, which gives us 2 to the power of 10 minus 2b. Now, we've got an equation where we have the same base, and that means the indices must be equal. So 3b equals 10 minus 2b. Adding 2b to the right and the left-hand side, we get 5b equals 10. And finally, we can divide both sides of this equation by 5. That gives us b equals 2. Here are questions E and F. The principle is exactly the same as before, except this time we're going to have quadratic equations to solve. Let's start with E. We've got 5 to the power of 9 equals 5 to the power of x squared. Now, we've got the same base in this case, and that means those indices must be equal. Therefore, 9 equals x squared. Now, be very careful in this situation. You might be tempted to say, oh, okay, we just need to take the square root and get x equals 3. But you will miss out on a solution if you do that. Just be careful. X squared equals 9 has two solutions. We can have the positive or negative square root of 9. So that's plus or minus 3. Remember, we can always check solutions by substituting them into the original equation. And if you try for yourself substituting x equals positive 3 into the equation, you'll see the equation holds. But if you also substitute x equals negative 3 into the equation still holds. And that means positive 3 and negative 3 are both solutions to this equation. Now, here's example F. It puts together all of the skills we've seen. We need to change a base so that we have the same base on both sides of the equation. And we've got powers raised to a power. And once you've got the same base on both sides, you'll find you have a quadratic to solve. Pause the video and have a go. Here's what you should have found then. 4 is 2 squared, and we've got that raised to the power of x, and we've got all of that raised to the power of 3. Now that equals 2 to the power of x squared plus 8. Now the left-hand side is a power raised to a power raised to a power. And we can find that as a power of 2 simply by multiplying these indices. So the left-hand side gives us 2 to the power of 6x, and that's equal to 2 to the power of x squared plus 8. Now we've got the same base, so we can just equate the indices. 6x equals x squared plus 8. If we subtract 6x from the left and the right hand side, you'll see we've got 0 equals x squared minus 6x plus 8. And that is a quadratic we can factorize. We get x minus 4, x minus 2. And this has two solutions. We've got x equals 4 and x equals 2. That means you could substitute either x equals 4 or x equals 2 into here, and this equation would still hold. Both of these are solutions.